What is up, guys? It is Aaron and welcome back to the channel. Welcome back to how to fix / build your RC car. Last time, well, first ever episode, we covered the basics of an RC car. So that was just the servo, the motor, the ESC, explaining what they do. And now this, and then the episode after that, we done the electronics of an RC car. Not going into too much detail about the electronics, just enough so beginners know what to do with electronics. And then we done battery safety. And this episode we are doing the mechanics of an RC car. And the mechanics of an RC car are going to be very different because again it's got nothing to do with electricity, it's got nothing to do with safety or anything like that. It's just to let beginners know about the mechanics of an RC car, what to listen out for if something's going on with your car and you don't know, oh well, if it's not up to the electronics faults, then you can kind of point out what's wrong and what's not wrong. So that's what this video is mainly pointing to, is again beginners like the rest of this how-to series, because again I don't want beginners to be going into the hobby and just not knowing what they're doing, spend money on an RC car and throw it away and not being able to fix it or do a project or anything like that. So if you're not a beginner, then you might want to just skip this video because you might already know a lot of the things that I know, well, or say. Okay, so the first things we're really gonna, everything that we're gonna cover in this video is gonna be the gears on the motor, the two-wheel drive, four-wheel drive systems, the lock differentials or the open differentials, lock differentials or open differentials, yeah. We're going to be talking about which one's better, which one's worse. And then we're just going to be talking about differential in general, then suspension oil, differential oil, hexes, wheels, gears, and servos, and all that other kind of stuff. You might be wondering why I have my electric drill out. I'm not going to be going off taking apart my car, because that's going to be taking hours and hours of work, and that's just going to take too long. The video is going to be like half an hour long. I don't want it to be half an hour long. So basically, my point is on bringing this out is that there are gears on almost everything that moves electronically. Your electric drills, your electric Dremel tools, your RC car motors, and basically anything that's electric that uses mechanics to move the end of a certain tool. Or are very, very simple. These are the, well, on the motor you have the driver gear and the driven gear. No, this is the driver gear and that's the some other gear. I can't remember what the proper engineering term of it is, but this is the driver gear because it's on a driven motor. Determine how much what kind of gears you need on your motor is always determined by your kV on your motor, because you do not want to overheat your motor by using too big of a pitch gear or using a gear that has way too many teeth on it. You can figure this out is using your kV times the voltage that you're putting in. So let's just say I have an 11.1 volt lithium polymer 3S battery, and this 3S, this 3000 kV motor was going to be used, and then you can determine the kind of gear you're going to need off of that. Obviously not the whole number, it's like the first two numbers that you get, that's how many teeth you should put on. So 3000 kV times 11.1, so it's going to be 33 teeth is the maximum you want to go for to stop this motor from overheating. It does depend on what application you're going to be using your car for. Gears work are very simple. You go off and have these two gears here and one drives the other. The motor moves clockwise, but then the gear on the differential moves anti-clockwise. So you've got to kind of think, okay, do I have this going anti-clockwise or clockwise, or which way is this going to be turning? And that's kind of something that's misleading to a lot of people when they're installing their first RC car motor is, wait, my car's going backwards when it's supposed to be going forwards. You can change that setting either using these poles here, you can go off and switch them around, or you can go off and have the setting on the receiver if you have a brushed motor. Using gear ratios as well is one of the biggest parts of your mechanical side of your RC. So let's just say I use 1.5 gear ratio. That's just going to be one gear to half the gear on this main gear here. So the driver gear actually has to be half the size of the gear here for it to function properly and to get the right amount of torque. Now you could use different gear setups as well. You can use 1 to 4 gear ratio or 1 to 6 gear ratio, so it has to be 6 times smaller than this gear here. And you can always change out this gear and then do the ratio by that. and it's just good to know what kind of gear ratio down and make notes on what gear ratios work the best on your car. Knows if something's wrong with one of your gears in this main part here is here. You can see that my gears have worn down quite a lot. And that's just because I've been putting too much power through this motor and the gears haven't been able to withstand that amount of power, and I've just been too cocky with the throttle, to be honest. Now, the kind of gear setup you're going to need for your different types of on-road, off-road, bashing, rock crawling, mud slinging or mud pulling or carpooling is quite a lot to take in, so sit back, relax, and try and understand what I'm saying. Start off with a pretty simple gear to one ratio setup. For on-road purposes, you need that perfect setup for your gears. So it can be either, well, it has to be for on-road use if you're racing on-road. It has to have a good amount of torque with a good amount of speed if you're racing for on-road. So you want to have good acceleration, but also being able to keep up with that acceleration and keep the speed constant as well. And the way you would do that for me is you would have the gear halved for racing, depending on what kind of motor you have. You're going to want to do the maths for that. If you don't understand what kind of maths I'm talking about, you can go off search online. There's probably hundreds of tutorials, hundreds of videos, and hundreds of websites that explain it better than I do. But basically, I would recommend half or a third gear ratio, just because it gives that good amount of torque and power ratio that you really need in on-road racing. For rock crawling is a very intense, well, not intense, it's a very complicated gear to one ratio. And I'd recommend, let's just say 16 to the 1 gear. So that's going to be 1/16th gear ratio. Just because that gives a good amount of torque, because again, rock crawling, you are not looking for speed, you are looking for torque, and you're going to need 4-wheel drive for that as well. Let's just say this gear here is around about 56 teeth, so I'm just going to go off and say 50 teeth just to make it a nice even number. Just because I have 50 teeth there, I'm probably going to need around about 11 teeth on the motor. And that doesn't really matter what kind of motor I have. It can be a good powerful motor that's strong and is like 1900 kV. It doesn't matter. For around about a 50 gear setup, I need 11 teeth. And there is the big argument of whether brushless is better for rock crawling or brushed is better for rock crawling. For me, as long as you have a setup that's right for you, it doesn't matter whether you use brush motors, brushless motors, tiny dinky brushless motors, or fat can brushless motors. If a setup works for you and it works well, then there you go. Say you're driving a buggy or a monster truck and it's 2-wheel drive and the ground that you're driving on is very wet and very slippery, and you're noticing that even if you go off with a little bit of throttle, that your car is spinning out of control and you can't control it in the corners, or it can't go in a straight line. That's because your torque is way too high for the car, and I'd recommend getting a higher gear on your motor. Or putting the main driver gear in the center here smaller, just so you can have a good ratio of that. But what you're always going to do is have your motor gear first changed. The middle gear here is a last resort, and you're always going to want to put that up a gear, never down, just so you're not increasing the torque. But to understand torque and power, there is a big difference between them. So I'm just going to go off and get a piece of paper and try and explain to you guys. I think I've done it in a past video, but I'll try and explain to you guys in an RC term. Now, the way to get more torque out of your motor, or just torque, is to always have your motor gear smaller than the gear on the differential. So that would mean that this gear is spinning faster by your gear ratio. So you times that by your gear ratio, gear R. So that is times by your gear ratio, or divided by your gear ratio, however you want to do it. So basically this will be a lot smaller and spinning a lot quicker than this motor here, which means this motor here will be going slower than this one here. Therefore, that is creating torque, not speed slash power. To get power slash speed, and the reason I say speed slash power, because power is equivalent to speed. If you don't have power, then you don't have speed. Then you just switch them around, to be honest. So you have a bigger gear on your driver gear, which is again your motor, and a smaller gear on your differential gear. And this little cross here is to tell you which gear is the driver gear, which one's the differential gear. Switching around them means that this gear will be spinning much faster than this little gear here, and this little gear here will be spinning a lot more less to turn the wheels, if that makes sense. So it'll have to be working less to turn the wheels. So again, you're just going to have an overdrive of speed slash power. For bashing, which is another term for just not going into any competitions with your RC car and just going out and having fun with it. It doesn't matter what kind of ratio you have. You can just go off, have fun with your car and not have to worry about racing spec gear ratios or anything like that. So you can just go off, have fun with your car and not have to worry about your gears or anything like that. Mudslinging, which is just going off in mud, or mud pulling, which is again just pulling weight out of mud. Or if you're just having tug of wars with your mates, torque is the winner, hands down. It doesn't matter how much power your car has, it will not be able to grip the same way four-wheel drive cars do with torque. Bring up four-wheel drive. Just going to start on the topic of four-wheel drive. A lot of people say two-wheel drive's better for this, no, but four-wheel drive's better for that, and it's like, depending on what you're doing, four-wheel drive could be good or bad for what you're doing. So on-road racing, four-wheel drive could be good, but you are going to have a lot of wheel bite and could risk flipping your car. Whereas in two-wheel drive, you're not going to have a lot of wheel bite, but you're going to have understeer in on-road racing. And modulating your throttle, you can get your two-wheel drive RC car to grip in corners on road racing. So that is why a lot of people use two-wheel drive cars instead of four-wheel drive, because you can get more torque out of them, you can get more speed out of them, and all around it's better for on-road racing. And that is just for on-road racing itself, not anything else. Now, off-road, two-wheel drive is, you can use two-wheel drive on off-road cars, but again, it's used on brushed off-road cars, mainly because brushed motors have more torque and less speed, because that's just how they're built, because they're brushed and not brushless. So again, brushed motors, with them being brushed, that gives them more torque. Brushless motors, they do have a lot of torque, but they also have a lot of speed, and that's why a lot of people go to brushless motors after they've used brush for a certain amount of time. The topic at hand, four-wheel drive is going to get you so many more places in when you're going off-road with your RC car, whether it be racetrack or you're bashing. It's just going to be so much more help, and like I said, four-wheel drive does get you almost over everything. Obviously, if you've got a bloody 90-degree angle, it's not going to go up over that. But what I'm talking about is if you're like stuck somewhere and you're high-centered on your rear differential, then you don't have four-wheel drive at the front to pull you over that. So that's why four-wheel drive can get you over a lot of stuff. Same goes if you're high-centered at the front, you can just push over it. You're wondering, how does four-wheel drive work? It's very interesting and very clever what RC companies have done to create four-wheel drive. And I will actually go off and take off this top part here if I can. I can't remember if I can or not, but I'm going to try to anyway to show you guys how it works. I don't have any tools with me at the minute to take this off and to show you what goes through the center of this car to make it have four-wheel drive. But it is basically one of these aluminum drive shafts. They are actually called drive shafts, the same as scale cars. So, and if you don't know what I mean by scale cars, I mean by real life cars and real size cars. So that's basically what's going along here. This one's too short because it's for my on-road car, which is still just, it's completely apart. And then what happens there is it connects up to one of the things here at the end here to slot into, and it goes into the differential. Now after this, there's a dog bone, is what I call it, between the A-arm and the upper linkage. So that basically goes across like that. The differential's in the center there. When that spins as well. So that's basically how they make four-wheel drive in RC cars. Differentials, I'm not going to go into, again, just because it will confuse a lot of people, how differentials work. Basically, I'm going to cover open differentials or locked differentials. Open differentials, which is what I've got on this car, so this is going to be a good example that I can show you, is when you turn one wheel here, the other one will turn in the opposite direction. And again, I don't know what the positives of that is, what the negatives of it is. I think it just saves the motor from, no, that's what it is, it saves the motor from straining, because if your wheels are locked up somewhere and the motor's not being able to move it, the differential can open on one wheel and blow off your tire basically, because that's what it'll do, because it'll surge all the power to that one open differential and the tire will balloon 3 times the size of it. Differential on the other hand, different ball game again. So basically if you go off and turn that tire, it's not going to be doing that. It's going to be going the same way, and if you get stuck again, you can go off and grip a lot better, which is why I am looking at lock differentials for this car. I don't think I'll be able to get them specifically for this HSP chassis, because that's basically what it is, because it's just a completely different car. It's my own make, basically, of car. It's not even a HSP parts anymore, it's just a whole load of random crap that I've just found on the internet. So it is just the chassis and the plastic on here that is the HSP original, and I've had this car for 2 years now and it's still solid. Well, the drive shaft and the dog bones slide into something. This is what they slide into. They slide into this little bit here, and that basically turns the wheel. And what you can do is you can go off, and this is how you can have suspension in your car as well, which I will go over, is that you can just go off and have any angle and the suspension can go up and down, and it's not going to affect the drivetrain of the RC car. Wheels attached onto, because obviously it is not just this it is attached to. What the wheel itself is attached onto is this 12mm hex. Depending on your scale of car, these hexes will vary in size. So you always want to read your manual to see what kind of size hex you have. A lot of the 1/10 scale cars use 12mm hexes. 8 scales will use 15mm hexes to 17mm hexes. And basically that just slides on like that there. But you can see that it goes all the way down and it's slipping. So if I can find a bit, I don't have a bit with me actually. So basically just pretend the screw is a little thing that goes through. So that'll slot through, and there's a little catch on the hex that goes into that, and it clips into place there. So it will not move out of place after that, and it will be able to spin your wheels. Simple but very, very effective. Now going on to servo. Servo's part of electronics, so I'm not going to go off and cover the servo. I've already done that in another video. But basically, your servo mounts for your steering are basically on pivot. So when I go off and turn this, the pivot points of the train for the steering is just on pivots. So it all just pivots on a point of metal, and it just pulls the metal left and right, and that's how your steering works. Well, it's something that I want to go off and cover up for your differentials as well as your suspension. I'll get into suspension a little bit later. Your oil for your differential is a must. If you don't have your differential oil good, or if you just don't have differential oil, put differential oil in, because differential oil, and it's not even oil, it's type of lubricant that's special. So it's like a little paste, it's like toothpaste, but it's grease. So grease paste I think it's called. So that goes into the differentials. You really don't want to cheap out on that, because it's got to be resistant to, one, heat, because if your gears heat up then they could easily melt and they can wear down. And again, to listen out for that in the differentials, it's going to be a very quiet grinding noise. So that's how you can find out if, yeah, fucker! Make sure your ESC is discharged before you touch the terminals. Sorry about that, but yeah, do not cheap out on your differential oil, because it will damage the differentials and you'll have to go off and buy new differentials, which are kind of expensive. Suspension and suspension. The way that your suspension works is your A-arms, which are on the bottom, and your upper linkages, also known as your upper A-arms, are on a pivot as well, same as your ESC. So the ends of both of your upper A-arm and your lower A-arm are on pivots. Same with your suspension links and your steering links as well, they're all on pivot. So the suspension can then be movable. Now to find the right weight, it is just literally just testing them and writing down which weights work best for your kind of setup. And again, it's not anything specific. Again, there isn't a perfect suspension setup. Everyone has a different suspension setup preference. For me, on off-road cars, I like a nice plush suspension that's really soft and grips well with the tires, because it isn't just the tires that give you grip, it's the suspension as well, because without suspension your car will just be stood still on the ground and it will not be able to push down on the tires and grip with gravity. I like plus suspension as well because it does make it really easy for this thing to wheelie. As well, I think I might actually change out my springs because they're just that little bit too hard for me. I don't want this because it's just popping up too quickly for me. I just want it to be like gradually, just so it can like mold to the surface that's on. But your springs are key in your suspension. So you're going to want to go off, note down what amount of foot-pounds, well, not even that, just how much grams of how much pounds of grams of push they give. Sorry, I'm really tired at the minute. Is it for this episode of how to build your RC car / fix your RC car. I think the next episode of this video in particular will be actually physically fixing the car, so I can just show you guys how to install some stuff, how to install your ESC, how to install your servo, how to install your motor, how to install gears on your motors, and just things like that. If there's anything that you guys want me to cover for series in the future, please leave it down in the comments below. If there's anything you want to know, just anything else about RC cars, leave it down in the comments below. Hopefully one of my subscribers will be nice enough to comment down and reply to you, or I can have it in for a next video. Really tired at the minute, guys, so sorry if I did seem like I was just a bit confused and a bit dazed. That's because I was. I'm just really tired at the minute. I've been working a lot, so you know, I haven't been able to sleep a lot as well, so that doesn't really help. But again, I hope you guys enjoyed the video. Please don't forget to like, subscribe, and share it with friends, and I'll see you guys in the next video. See ya!